So in the previous discussion, we talked about that the 1 plus 1 by n raised to n. So let me write it here. Maybe I can use a comment. 1 plus 1 over n raised to n. This particular sequence was monotonically increasing, and we also want to show it's bounded. So I sort of want to create a little program that will show that it's indeed bounded, and maybe it can also show us how fast it is increasing, its value is increasing. If you have not watched the previous video, you can go ahead and look into it. We showed that it is a monotonically, so maybe I can write it here, 1 plus 1 over n raised to n, or in more geeky manner I could write star star n, meaning raised to n, is a monotonically increasing sequence, and we showed it using we used AMGM inequality. It was a beautiful proof. You should go and see in the previous video. But what is the goal in this particular discussion? We want to check how fast, or rather what values this sequence can reach. So let's try that. So we will take a value from the user, and maybe that value is the bound. So what upper bound you wish to check, and let's define the index value or the input value n, and let's set it at 1, and let's check the value of the bound, or rather the term value. So we will set it at 0, and then we will progressively increase it. Alright, now let's use a loop and make sure that this value is less than float of the bound. So as long as this happens, we will keep on doing whatever we are doing. So value is less than the bound, then we will put the term equals to 1 plus 1 over k raised to k, and put this value inside, put the term value inside the variable value, and now we have to check if value is less than float bound, or in fact if it's greater than float bound. If it is, then we will print, I missed a colon here. If it is, then we will print k, else we will just put k equals to k plus 1. So we will increase the input value, and we will keep on doing this. Alright, so this is the deal, and expected result is it will give us the input k for which the bound that we specify will be exceeded for the first time. Okay, now let's run this code. So let's suppose I want to check 2.2. So you can see for k equal to 2 it exceeds it. Obviously k equal to 2. Let me just put a comment here. So for k equals to 2, we have this 2.25, so it exceeds 2.2. Okay, let's execute this one more time. Suppose we want to check if it's exceeding 2.7. So for at 74, that happens for the first time for k equal to 74. Okay. In fact, we can just print term, so we can see exactly what value we get, and we can print let's say 1 plus 1 over k minus 1. I'm not sure if this is going to work, but let's see. Terms times k minus 1. Yeah. So we can check all of these things. Okay, now let's just print it. So again, let's say 2.7. So yeah, at 70 we have that, and actually I missed a bracket here, I think. Okay, yeah, now it should work. So now again, let's say 2.7. Yeah, so at 74 the value is 2.700 whatever, and at 73, the previous one, it was 2.699. So okay, now let's check for 2.71. 2.71, if that's the bound, we want to know at what value of k this works. So at 164 it exceeds 2.71, and at 163 it was just below 2.71. So a little simple code that can tell you what's happening in this sequence, 1 plus 1 over k raised to k. But we need a more analytical proof of this fact that this particular sequence is bounded, and we can achieve it using a simple comparison test. Alright, keep watching and doing great mathematics.